Okay, here are some instructions and hints for PGSS Homework 1 for Computer Science. To start, go to this link, cscmu.edu/112, which you go right here, and there choose Spring 17, go to Schedule, and look at Lab 1. In Lab 1, you will find problems. We're only going to do a few of them. We're going to do numbers 3, 4, and 5. So we're going to read carefully right now about is perfect square, get kth digit, and set kth digit. Read those problems. Next, you're going to want to go to this link, our Auto Lab, which will also be posted to Piazza. And you go to that link, and here are the files you need for Homework 1. So you can download the starter code for Homework 1. It didn't download it, so go ahead and save, and it'll put on the desktop, which is fine. And so here's Homework 1 starter file. When you have that, you have to also download the linter. If you don't have the linter, when you run this, it'll just say no linter. So go ahead and download the linter. So we'll do this and save that. You never edit the linter. It just has to live on in the same place, in the same folder as where you put Homework 1. You only edit Homework 1. So now I have the files, and I've carefully read the problems. So now I can go and edit the files. Okay. So here, you'll notice inside this file that you have the 3 problems that you're supposed to do with placeholder solutions and the test functions down below. Very much like what we did in class. Do not edit the test functions. Do not anything down here. Just edit the part of the code that says return 42. That's what you're supposed to replace. Okay. Now, when you think you're done, which presently naturally I'm not, because if I run this, I'll fail immediately on is perfect square 0, which was supposed to be true, but mine was 42. Well, of course it was 42. There it is. Well, if you had these done and you wanted to submit your work, you would go back to AutoLab, click on Homework 1, and after you say I have affirmed the academic integrity policy, you can click Submit, choose your file, homework1.py, and you get this screen right here. Okay, so ignore this previous submission, which I did in a previous example. This right here is my submission. And there's no score because AutoLab is actually auto-grading it right now. In fact, mostly what it's doing is just waiting for an opportunity because there's other things it's auto-grading. So what you have to do is reload this page until you get a score on your submission. I scored 0, which is not surprising because after all, I haven't solved the problems. But don't just look at that. Click on that score, and that will give you much more information. It'll tell you why you got the score. For each problem that you did not get right, it'll tell you why you got it wrong according to the autograder. The test case, what you're supposed to get, and what you actually got. And notice they're different, so I got that wrong. So look at this carefully. In this case, for is perfect square, get kth digit, and set kth digit. This is invaluable to help you go back and fix your submission. Fix your code before submitting again. Okay, a few more important hints. So we did not talk in class about how to tell if something is a certain type, and that's required for is perfect square in particular, because is perfect square is going to ask you if a string is a perfect square, which of course it's not, but you can't crash while you're testing that. So if I wanted to test if the number 42 is an int, I say is instance 42 int. Is instance, pardon me, 42 int. And in fact it is. Is 42 a float? It is not. Is 42 a string? It is not. Well, how about this is a test? That's a string, so is it an int? No. So now you know you can test if something is an int, is say a variable x, by saying is instance x int. And that'll tell you true if it is an int, or if it's not an int, no way, the test will tell you false. So is instance is important, and you'll need it. Also, you have to know about rounding, okay? So rounding in Python 2, and I'm going to show you Python 2 here just for a moment. Round 1.5 does what you think, 2.0, round 2.5, 3.0. Great, but we're not using Python 2. We're using Python 3. And in Python 3, round of 1.5 does what you think, and round of 2.5, you might be surprised to learn that that's also 2. Many students find this counterintuitive. It's called round to even. It's a perfectly legit way to round, but a lot of students are surprised by this, and they're expecting other behavior, so their algorithms fail as a consequence. So because of this, the linter actually does not let you round. If I were to go inside here and try to round then, which is still wrong, but if I just tried to do it, the linter will actually fail and say, hey, you can't actually, do not use built-in round in Python 3 because the behavior might be unexpected. So instead, it tells you what to do. It tells you straight up, use this function. It gives you the code. You copy this code, you go here and you paste it into your code here. And now I can use this round half up function. Round half up. That does what you'd expect. And I run this, of course it's still wrong, but round half up of 1.5 is 2, and round half up of 2.5 is 3. So don't use round half up. And why would we ever use round? Well, it turns out round could be quite handy for is perfect square. Because, well, let's look at this. 25 is a perfect square, and the square root of 25, which I could do that way, or if you'd rather, I could do it this way. In any case, the square root of 25 is 5.0. 26 is not a perfect square, and the square root of 26 is 5.099. So something's importantly different about how those square roots look. And if I were to round those square roots and then maybe square them back, maybe something interesting would happen. I've said too much. All right, as for kth digits, here's a hint as well. In class, as you recall, if we had some number, okay, say n is 1, 2, 3, 4, 8, 4, 3. Okay, there's n. And I want its ones digit. We covered this in class. N mod 10 will give you the ones digit because it's the remainder when you divide by 10, which will always be your ones digit, at least for positive numbers. Okay? So as for the tens digit, how do we get the tens digit? We did that in class. If you integer divide by 10, that's the same as simply deleting the ones digit. So to get the tens digit, you could move the ones digit, remove the ones digit, and then take the remaining ones digit. So I had a number. Here's my number, 1 blah, 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 843. When I integer divide by 10, it's the same as getting rid of that 3. And then when I mod 10, it's the same as taking the ones digit at that point, which is 4. So this gives you the tens digit. So I'd ask you, how do I get the hundreds digit? Hopefully you said something along the lines of that, which now finally is enough of a, oh, and by the way, I'll even rewrite this for you. I'll let you think about what I just did and why that matters. But if you follow what I just did and think about the problem statement, that's a strong hint for how to solve get kth digit. As for set kth digit, the hint I would give you is first, get rid of the existing kth digit. Remove it somehow from the number. Then add back this new kth digit. Don't forget to read your problem statements. It's very important to understand the problem. Don't forget to look at your test cases here and try to get your code to run completely before you submit it. Finally, I'll submit a working solution just so you can see what that looks like. Go back to homework 1, submit, affirm and submit. I'll go to the desktop. I actually have the solutions here that I wrote. And we'll get to this screen. Of course, I have to wait. So I reload. And I still have to wait. So I reload. Still have to wait. And I reload. And after enough patience, eventually, I got 100. And when you have 100, you're done. Don't forget to work with each other without copying code. Critically, do not copy code. Work with your TAs, Corey and Aiden. Use Piazza and do your best. Don't stress over this, just do your best. Good luck.